Hello, hello, hello. Welcome back again. Today is still Thursday, the 30th of July. I paused stream for a bit there because I was getting this weird error message saying that it was my internet connection was unstable and it was trying to reconnect. So I stopped stream in case all that stuff got lost. I listened to it back. It seems okay. So hopefully it wasn't too bad. And I'm kind of going to just pick things up where I left off. So I'm going to put you guys over. In fact, for anyone who's watching this fresh, what have I been doing? So I went through, I did a complete PAT test to show how you can use those for your ESAT prep. While on stream, someone talked about the ECAA, which is a paper I was trying to find that I completely forgot about. And I did a speed run of the section B of paper 1, which is the closest to the ESAT Math 2. So I did that run. Apologies if you didn't see it. I'm now going to kind of mark it. I haven't completely finished it. So I did all the stuff that was like the ESAT, and I did that timed with splits. Now I'm going to finish it off for the bits that are closer to the TMUA, and then we'll mark up and kind of analyze. So if I get that reshared. So we got this far. I'll explain what happened. I think it should be fine, but I'll re-explain it if I need to. But now, getting into the TMUA part of the paper. So we have these numbers, and we consider these statements. Which of these must be true? If A is less than B. If A is less than B, I think this does have to be true. Let me check that. So if A is less than B, let's do so. So like if A was minus 100. Oh no, that doesn't have to be true. Because if A is minus 100 and B is 1, that is true. But if I do that, then that's still negative and that's still positive. So that doesn't have to be true. So TMUA is very much coming up with counterexamples. Does this need to be true? Does this need to be less than this? Well, it's 2 to a power, and that is 2 to the anything is going to be an exponential function. And if A is less than B, then it is guaranteed that that is true. So 2 is guaranteed. And C is not 3 is not guaranteed because I can multiply by a negative number. So only 2 has to be true, which makes the answer C. So here, a curve is a cubic. The curve has a maximum stationary point at x equals 0 and a minimum stationary point in the fourth quadrant, which is sufficient to ensure this, which does the job. So let's first find these here turning points. So it's x into 3ax plus 2b. So we know there's a turning point at x equals 0 as given. We know there's a turning point at x equals minus 2b over 3a. And we know this is the fourth quadrant. So 1, 2, 3, 4. So we know that this thing is bigger than 0. And we know when I plug that back in, so let's find what the y is. Oh, the y is some nonsense. I could try it. So that cubed, so that's going to be minus 8b cubed all over 27a squared plus 4b cubed all over 9a squared plus c. So that's not too bad. So that's 12, 27. So it's 4b cubed all over 27a squared plus c, which also has to be less than 0. Do you recommend TMUA papers for the ESAT? I recommend some of the paper 1 stuff, certainly. Those are challenging, though, and they're not the same time constraints. So it's 3 minutes per question as opposed to 1.5 minutes per question. So you get a bit more. If you're seeing stuff delving into the necessary and sufficient, which is more of your paper 2, feel free not to. So I do recommend paper 1, but not paper 2. So which of the following is sufficient to ensure this? Well, we need this. Okay, let's eliminate. So we need, in other words, A and B to have opposite signs. So that's not true, that's not true, that's not true, that's not true. Okay, so out of these, cool. So if A and B have opposite signs, then you could have B negative, A positive, which makes that negative. If A is negative and B is positive, then you certainly need C to be not just negative, but rather negative. So in other words, it will do if B is negative and A is positive and C is negative. That will do. So B negative, A positive, C negative gets you there. That's E. That one works. Electronic circuit contains 3 light bulbs, which are either on or off at a particular time. It is known that if bulb X is off or bulb Y is on, then bulb Z is on. Huh. Okay, here's what I'm going to do. So we have a condition and we have a result, which is so true, false, true, false. So what we're saying is if the condition is true, then it is on. So you don't have this, but you can have this and you can't have that. So it necessarily follows that if bulb Z is off, then neither of these things is true. So it follows that if bulb Z is off, then both of these are false. So X has to be on and Y has to be off. What? I don't think it's any of these then. But there's no restriction. If bulb Z is on, then there's no restriction on where that comes from. I genuinely think all of these are wrong, and the answer is if bulb Z is off, then X is on and Y is off. I'm going to check the answer on that. Let me see about this, though. So the total is 1680 kilograms for 20 people. When n people leave, the mean is reduced by 3. The mean for the who left the group. So when n people leave, so the total mass becomes n times the mean of those n. That's the total mass. Total mass over the total number of people, which is 20 minus n, is the new mean, which is 81. So 1680 minus n mu equals 1620 minus 81n. So 60 minus n mu equals 81n. We want to rearrange for this. So 60 minus 81n equals n mu. So the mu is 60 minus 81n over n, which is 60 over n minus 81, which is a. So that's all of those. Let me check my working, and I don't think I need to re-explain what I did necessarily. Answer sheets. Let me first, oh, that's the answer sheet. That's not the solutions. I have answer keys. That'll do. So 23, we're starting. I got D is good. D is good. D is good. I'm proud of that one. I'm proud that I skipped that one and came back to it. That was good exam technique. So that is C, which is good. 27C is good. 28B is good. 29B is good. 30B is good. 31D, 32D, 33E, 34C, 35E, 36E is correct, but I still maintain that's wrong. That's just not correct. That's genuinely, I believe that's wrong. And then 37E, and I got that wrong because it should have been plus. Oh, I changed the sign. Oh, sign error. Guys, god damn it. All right, no, you're right. Yeah, that was a sign error. That actually was a legit mistake. So I apologize for that. Let me go through and see if there were any interesting techniques for the ESAT in here. This felt very ESAT. This was kind of, actually, let me have a look at my split times and do some split time analysis for you. So the first one, I got this done in 1 minute 11, which is good, less than 90 seconds. So this was fairly self-explanatory. Would you say these are harder than TMUA? No. These are in line with ESAT and are easier than TMUA. I would say when you get to those ones that I did, those slower ones from question 30, yeah. So from 34, this is in with TMUA. TMUA is just technically very difficult. It's just not as exam technique difficult. So conceptually it's harder, but it's easier to execute because you've got 3 minutes per question. So this is a very TMUA question. All of these are very TMUA questions, except this, which I still maintain is literally wrong. Because I think they had to negate the or. The opposite of that is neither. It's and. That should have been an and. Okay, so, but I digress. So what was I saying? So this is 1 minute 11. What did I see here? I laid out the first 3 terms of the geometric series, and I laid out what the differences were for the first, fifth, and sixth of an arithmetic. So the difference there to there is 4D, and there to there must be D. So that let me set up equations, which I eliminated D from the first 2, and set up a quadratic, which I solved and found R, given that R can't be 1. This is extremely ESAT for some reason, getting the distance between the roots. So you do it by doing the quadratic equation and then getting that sort of, it's the plus square root over 2a and the minus square root over 2a. So the distance between them is the root of the discriminant over a. And from there, you're good to go. This one, very good skip. I took 23 seconds to skip. I just realized I wasn't getting it. So it was a good skip. And when I came back to it, it took like nearly 3 minutes. So that shows another, again, that it was justified skip. What did I do some wrong here? I was getting confused about millimeters and centimeters. So my units weren't great here. I like that I got there in the end by relating the area of that with the area of a sheet being 250 millimeters by T. It would have been better if I'd maybe called that. No, I should have worked in millimeters the whole time. So that's fine. So I worked out the area in centimeters cubed when I should have made that millimeters squared, sorry, which would have involved dividing by 100. So it's 2.5 T in millimeters squared. So if I'd made that 2.5, it would have been fine. And if I'd made it 2.5, it would have been even easier because then taking the 4 would have made it 16 times 10, which, yeah, just taking off those things. So I like that I did difference of 2 squares up here to make that nice and simple. Everything canceled down quite well. So happy with that. This, I was happy with how I didn't actually calculate these things. I just left it factorized and then took it out, and then things canceled down further. That's very ESAT skill to give you that 44% increase. This is just such a classic. This is an optimization problem where you find one of the variables that you don't want. In this case, from the perimeter equation. So perimeter equation gives me theta in terms of x, which I can sub into the area equation and then optimize that, differentiate, set to 0. So classic from the textbook that. This is a very classic ESAT. It's also very classically TMUA. So TMUA asks a lot about sort of roots of cubics by placing where the turning points are relative to the x-axis. So I found that x-axis, and then I said the y has to be bigger than 0. So by plugging in x equals 2, that gives me an inequality for p. Here, this is just simple log stuff. I knew I wasn't going to factorize that in time. Although what I probably could have done it, because the target number was minus 600. And that would have been 20 and 30. Yeah. So it would have been 25x minus 30, 25x plus 20 all over 25. And a 5 cancels from both to give you 5x minus 6 into 5x plus 4, which would have gotten me there. So it was doable, but I just didn't see it. So I used the equation because of the time pressure. And I haven't been checking my timing. Let me do more of that. So again, this was from the top. 111, 1 minute flat, 23 seconds skip, 54 seconds solve, 113 solve, dead on the money, 1 minute 30. And another dead on the money 1 minute 30. So then we get into, so this one was 42 seconds. This was fine. And the reason why this was fine was because I was able to kind of, normally these sorts of speed equations I know really trip me up conceptually. But here I was able to do this quite well. So working out if 1 hour gets me 10 kilometers, then half an hour gets me 5. So I got that 30 minutes from there. And if 1 hour gets me 30 kilometers, then I've done a third of that. So I've taken a third of the time. So adding those together gets me 50 minutes, which is 5/6 of an hour. So it's the total distance of 15 kilometers over that 5/6 of an hour, gets me the 6 over 5 times 15, which is my 18. This I bombed because I didn't sketch it. I should not have fallen for that. So sketching it to think if some of the areas above and below, because if I did the integral straight from minus a to a, the area above and area below cancel, and it doesn't work. So I should have done them separately and then added them together. Here, this was quite nice. So this can be quite hard to understand conceptually, but it's the shortest distance parallel to the y-axis. So you want to minimize that vertical distance there, which is the top one minus this one, which is this expression. So that expression gives the difference in the y values, and we want to minimize that. And so I completed the square. This one was silly. I don't know why I didn't remember it's blue and blue. Therefore, I should have multiplied those together. But from there, it was relatively self-explanatory. And then, like I say, I've explained these getting into these. So the total time I took on the ESAT part was 19 minutes and 10 seconds. Let me check how many questions that was for. That was for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions. So 11 questions times the 1.5 minutes. That was over time. That was over time. I should have taken 16 minutes, 30 seconds. So I was 2 minutes and 40 seconds over. So basically that last question I did. And the last question I did was actually, well, if you look at then, that last question I did was this question 25. So what it means is that I wouldn't have got back to it, but it does mean I completed my first pass in time. That is the whole point of the multiple pass strategy. It means that I got to all the questions I could do, and I made it all the way through, and I saw every question, and the only question I missed out in time was one I couldn't understand anyway. That is ESAT technique in a nutshell. So yeah, and it also shows you how fast it was. That as fast as I was doing that, it wasn't fast enough. And the reason why it wasn't fast enough is because I had to go back and redo things because I got them wrong the first time. So yeah, arguably, once I got them wrong, I should really have skipped and come back to them with fresh eyes. But yeah, I'm pleased with that as a sort of demonstration of the multiple pass strategy for ESAT. Just it's always good to have a reminder. And as I said at the start of the first stream, it's important at this stage to get one good ESAT run in so you can kind of see what your timing is like. Do you need to get faster? Is there something you're not understanding? Is there something that's falling down when you're trying to do the papers? That you need to then work on that technique in isolation and build up that strength at speed. All of this is such helpful information. And look how much time I'm spending going through the post-game analysis of my speed work, really thinking, is my technique, like, could my technique have been better? How could I have spotted the right solution path immediately as opposed to needing to redo the problem? There's just so much juicy stuff to analyze there. So the ECAAs, I would recommend for your Math 2 prep, and I think definitely start adding those into your repertoire. Would you say, so with TMUAs, what I want to do now, actually, let me show you how you can use maybe some TMUAs and a little bit of the MAT test. So let me get some MAT tests. Let's see if these are any good. So looking at MAT tests, I'll go to MAT 2007. So showing you how what the MAT test is and how you can use it. The MAT test was initially the test to get you in for math at Oxford? Yes, at Oxford, which again, now the MAT test has been replaced by the TMUA. So the Cambridge papers have won. The MAT test and the MAT test and the PAT test have both died. So this is the first year without them. So showing you what a TMUA looks like since it was requested in chat. Oh, sorry, this isn't TMUA, this is MAT. The way I would recommend it, if you are going to do this, you will only do question 1, which is the multiple choice. And again, this is a little bit more pure mathy, but some of the easier questions at the beginning, you can see have a bit of an ESAT flavor to them. So this one, let's split this out into 2s and 3s. So that's 2 to the r plus 3 times 3 to the r, sorry, that's s, r plus s. And that's 2 squared. So that's 2 to the 2r minus 2s. 2 squared times 3, so 3 to the r minus s, all over 2 to the 3r times 3 to the 2r plus 4s. So combining all the r's, that's 3r minus s all over 2 to the 3r times 3 to the 2r all over 3 to the 2r plus 4s. So that's 2 to the minus s times 3 to the minus 4s. So it's 2 to the s times 3 to the 4s all to the minus 1. So when, oh no, this isn't. This is the very TMUA, actually. Maybe not that ESAT. Good for a stretch, but not very good for a specific ESAT prep. When is that an integer? Ah, sorry, there's a better way of thinking about this. We can take that, we can say that's 2 to the minus 1 times 3 to the minus 4 all to the s. So if s is negative, that flips that round, makes that positive. That works because that's 1 over 2 times 81 is, so it's a 1 to the s. So it's, in other words, it's 162 to the minus s, and that's an integer when s is negative. So B. Here, love this, the greatest value of this. So first of all, we know sine squared varies between 1 and 0. So when that is equal to 0, f of x is equal to 49. When that is 1, it's equal to 16. And when it's equal to, well, it can't be 7 over 3, so that can't ever get to 0. So I'm going to say 49. Because sine squared is limited to values between 0 and 1. So those are the extreme values. Yeah. Yeah. So that's certainly correct. Number of solutions. This is ESAT. Number of solutions is ESAT. So what you do is you say, so that it's worth picking apart sort of mat test question 1 to see if there's anything interesting. So 7s plus 2c squared equals 5. So 7s plus 2 into 1 minus s squared is equal to 5. So 7s plus 2 minus 2s squared equals 5. So 0 equals 2s squared minus 7s plus 3, which is 2 sine into sine minus 3 minus 1. So either sine x is equal to a half, or sine x is equal to 3. We know sine x can never equal 3. So in there, it has 2 solutions, which is specifically pi over 6 and 5 pi over 6. Point on the circle here, which is closest to that. We're obviously going to sketch this out. So we have 5, 4 with the radius, and then we have this guy, which is 1, 1. We're going to draw the lines connecting the centers. That is 2, that is 1. Now so the point on this circle, which is closest to this circle, will be this point here, which we are trying to find. Okay, what we can do, actually, is sort of do a similar triangle situation, where that goes 4 across and 3 up. So if it goes 4 across and 3 up, we know it goes 5 down. So we're looking for one. Now we got 2 closer to it. So we want to scale that so that becomes 3. So we're multiplying by 0.6. So that becomes 1.8, and this becomes 2.4 across from here, where this is the 0.11. And so it's going to be 3.4 and 2.8, which is that one. Oh, that looks ugly. What do we see here? If these are integers, then this thing is, well, this thing is, that's always positive, that's always positive. If n is even, the entire thing is positive. So no. Maybe? No, because if n is even, then it's all squared and anything there has to be positive. So when is this thing negative? So it's negative when n is odd. So it wouldn't, C can't work because if n was even multiple of 6, for instance, then it wouldn't work. And again, I think n has to be odd. So I think that just automatically makes it B. Yeah. The equation, this thing, so that's 2 to the 3x plus 2 squared equals 2 to the 2x plus 2 to the x plus 2. So 2x all cubed minus 2x all squared minus 4 lots of 2 to the x plus 4 equals 0. Guys, that's bananas. Because if we set that, then you get an actually quite factorizable cubic by using your factor theorem. So we can see that when we plug in 1, we would get 0. So one of the factors has to be y minus 1. And then it's going to be y squared. No, come off it. Minus 4. Y equals, yeah. So it's y minus 1. Guys, this is such a delightful little question. Look right at that. Look at that. All right, so that's y equals 1 or 2 or minus 2. But remember, y was equal to 2 to the x. So 2 to the x is equal to 1, which means x equals 0. 2 to the x equals 2, which means x equals 1. 2 to the x equals minus 2 has no solutions. So there are two values of x. C. Charming question. Oh, no. Okay, so we have this thing. When x equals 0, that 0, 1 over 2 to the, so that's, it should be 0, so it's not this guy, it's not D. Okay. This thing is always positive, this thing is always positive, it's not B. When does sine squared of x squared equals 0? That happens whenever x squared is equal to n pi, which means that x is equal to root of n pi. So when n equals, so these ends I think are getting closer together. So I think it's A. It's not a constant interval. So I'm going to go for that. This is very TMUA. While we're here, though, so that's 3 times the integral from 0 to 1 plus 2 times the integral from 1 to 2 is 7. And this guy is the integral from 0 to 1 plus the integral from 1 to 2 plus another integral from 1 to 2 is equal to 1. Simultaneous equations. Let's subtract them. So 2 integral 0 to 1 equals 6. So the integral 0 to 1 is 3. So the integral from 1 to 2 is minus 1. So the integral from 0 to 2 is that all added together, which is 2. Very TMUA. So not very ESAT. Given A and B are positive and this thing, then the greatest possible value of A is a thing. Do I know how to do this? Well, that's an ellipse, isn't it? I wonder if I've got as much useful productivity time out of my brain as I'm going to get. Let me, given that A and B are positive. How are we going to do that? I'm going to be cheeky now. I'm going to plug them in. Oh, guys, I'm being an idiot. Right, so log 10 of b all squared has to equal 1 minus 4 log 10 of a all squared. This has to have solutions. In order to have solutions, anything squared has to be positive. This thing has to be positive, which means that 1 has to be bigger than 4 log 10 of a all squared. So a quarter has to be bigger than log 10 of a all squared, which means that log 10 of a has to lie between minus a half and a half. So the greatest possible value of a would be when it's equal to a half, which makes it C. Okay. So the inequality, this nonsense, is true for all n bigger than or equal to 1. What's the restriction on k? So that is the sum from 1 to 100 of n squared plus the sum from 1 to 100 of the natural numbers, which is 100 times 101 all over 2, so 50-50. Now, the sum of the squares, I do not remember off the top of my head. Oh, wait, but am I summing? Oh, sorry, that's not true. Sorry, we're summing from I equals 1 to 100 of n to the power of I squared. That's a totally different thing. Okay, why don't we take the limiting case? In the limiting case, n equals 1. Oh, if that's true, then it's just this guy, which is 50/50, plus another 100 n's, which would be 51/50. And k has to be less than that, so the answer is D, because that's the most restrictive case. Love that. And we're done now. So let me see. Where did my math test go? Please pause while I find where I even got this from. Hold on a minute. There we go. So that's 2007. Let me get the solutions over here. Sorry, I've got so many tabs open now because I've done so many papers today. I mean, that's the opposite of a problem. Hopefully it's very helpful, but let me go through and see this. Again, less ESAT, very good to like challenge you. So B, C, B, A, B, C, A, D, C, D, love that, and done. Right, so those are all correct, which is good. How am I? I'm doing well, thank you. I took a nice holiday to the Lake District over the weekend, which is quite nice. Oh, why are they trying to call me? I'll call them back. So when are we doing? So when we are doing ECAAs, TMUAs, etc., do we still follow 90 seconds per sec question? No. Rather, hold on. If you think that something is appropriate for ESAT, then do it to 90 seconds a question. So that applies to the ECAA Part B. This does not apply to TMUA, which is has 3 minutes a question. So only do it if it's like bang on the money. Now, that might leave you feeling like you're not doing enough time pressured work, which is why you do your speed runs of your GCSE papers or your AS/Solomon papers. It's also why you can do your sprint work with like a ChatGPT or something like that. Things to work on that speed work in isolation while you continue to develop your syllabus mastery and making sure you're getting to the right level. So your TMUAs and a lot of these things can push you past the required level. The PATs can push you past the required level. So when you bring the two together, the ESAT questions feel easier and you have the speed unlock from when you practiced it. So hopefully bringing those two together is like the way to go. Like I say, now is a good time to put in a first proper ESAT run so you get a sense of where you're at and where you need to target. I don't think I'm going to sit down now and get another run of a paper out. Let me check the TMUAs and see if there's anything interesting in there. I know I have done a paper one run in the past. TMUA past papers. Is this going to be worth it? Let me have a look at paper one. "75 minutes, 20 questions." Not really. No. It's useful to push you, but again, it's not very ESAT. I mean, it could be worth it. I'm not going to run it now. I think that's enough to show you, because now what have I shown you? I've shown you how to use the NSAA/ENGA, in fact, just the NSAA Section 2s from 2020, which were very good. NSAA Section 2 pre-2020 was bad. PAT tests, especially the multiple choice, is good. Some of the others can be good as well. The ECAA can be good for your Math 2 up to a limit. Your MAT test can push your ability, but it's a bit more TMUA. So it's kind of showing you, it's making sure I'm kind of giving you a bit of everything so you can pick where you are in your process and what you need to challenge you to get to the next level. So hopefully you've got a good sense of that today. Where do I need to do moving forward? I need to prep you guys for those of you doing chemistry. So I should do a spec. I should do some things there. And I also know that none of my previous runs included chemistry for the ESAT. So maybe it would be good to do some runs of that, maybe to time to kind of show you how I would use my multiple pass strategy for that. So chemistry, let's put that on for next week. I'm not sure you guys are going to get as much out of me speed running GCSE papers, but it's something I can do if you want me to sort of like put up challenge times for you to target, right? So I put up a run of 18.5 minutes. Some of you might want to do it quicker than that. That I can kind of leave up to you. And yeah, that's kind of where I think we are. I think we've done a lot of work on the syllabus. I've done a lot of work showing you the different papers you can use to prep. And I've given you the strategy of how to sort of prepare the syllabus material and get your speed up so that you can bring the two together. Now is a good point to put in a test run, see where you're at, and see what changes you need to make in August while it can still be your priority. Then when you get into September, you're feeling confident you can start burning through papers when it's closer to the time. And that sounds like a plan. So I'm going to return this call because this person's called me before, and this is some sort of corporate number. So I got to find out what's happening there. In the meantime, I will see you guys at some point next week where I will hopefully give you a bit more notice. Maybe Monday. Monday would be very good. Maybe Monday morning. It's very likely to be Monday morning. I'm going to put notice and kind of stick that up. But right, I will see you guys next week. You are very, very welcome. I'll see you then. Take care. Bye-bye.